If you wonder what is the Gateway API, then this episode is for you. Welcome to Is It Observable? Today's episode is part of the Kubernetes series where we covered several episodes. We covered how to collect logs in your Kubernetes cluster using several solutions like FluentBit, Stanza, FluentD, and so on. We looked at what is a service mesh with what is Istio, what is Linkerd, the power of Kubernetes events, how to measure the cloud cost, and so on. Today's episode will be focusing on an exciting and popular project named the Gateway API. You probably have heard about it, but you may ask yourself, what is the value and what does it really mean? Well, we're going to answer to those questions in this episode. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. As usual, we'll start with an introduction on how we manage our traffic in our cluster. Then we will see what is the Gateway API. We will look at the new CRDs introduced by the API Gateway, and as usual, we'll jump into a tutorial. Like explained in the episode dedicated to Service Mesh, or the one related to Cilium and Humble, to route the traffic in our cluster, there are several ways of doing it. To expose a service out of the cluster, we can either rely on services with the type load balancer or the service type node port. But the common way of doing this is by using Ingress controllers. The other options is to rely on Service Mesh. That will provide egress and ingress support as well. To filter or to limit the traffic in our cluster, we can easily rely on network policies that will allow us to create L4 rule based on IP addresses. The network policy can be easily upgraded by utilizing solutions like Cilium that will provide L4 to L7 network policy rules. If you want to learn more about Cilium, check the episode related to it. Deploying our workload in Kubernetes is great because we have the options to share the infrastructure with several teams. With such a platform, we have obviously different personas working on the platform. There is the project team, the team working on applications, deploying their code in their own or several namespaces. Then you have the platform owner or the operator that will be responsible of all the common tasks. So the security aspects of the cluster, the network policies that we need to implement in the cluster, and the global observability that needs to be set up in the cluster. So when managing our Kubernetes network with this type of organization, we are facing a couple of challenges with the current way of dealing network in Kubernetes. First, if we look at the Ingress, to configure an Ingress role, it will hold different type of information. It will hold the TLS settings and the route. Basically, everything with one CRD. So who is responsible of this CRD? Is it the team or is it the platform owner? The other use case is the network filtering or the network rules that we want to apply in our cluster. I mean, if you want to define which services or namespace can talk to another services or namespace, this can be configured using network policies. In this case, it's clearly a task that will be in charge for the platform owner. No issues in this particular use case because at the end this is configured through one CRD, the network policies. If you're using a service mesh, it is much more easier to split these responsibilities within the teams because building a network routing rules require to configure a gateway, a virtual service, and a service entry. With a service mesh, our platform owner will be in charge of the control plane that will configure the gateway and the service entries. And then each project can configure their virtual services to expose the services using a specific gateway. As explained in the episode related to service mesh, like the one on Istio or Linkerd, service meshes provides more than just routing traffic rules. A mesh will allow us to manage a multi-cluster network, to create traffic split rules, to create rate limits, to create retry rules, circuit breakers, and way more. So if you want to create a traffic split, it is mandatory today to rely on a service mesh. In fact, not really, because we can technically define traffic split rules using Ingress rules. But creating those type of rules will be done using annotation. Again, the annotation will be specific to the implementation that we're using for our Ingress. So remember, Kubernetes provides the API, the Ingress, but you need an implementation. So it could be Nginx, Kong, or others. And each of those implementations has their own annotations. Out of adding the annotations in our Ingress policies, we will have to create 2 Ingress rules to create the traffic split. So much more difficult to maintain over time. Currently in the networking space, there is an exciting project managed by the SIG network named the Kubernetes Gateway API that will resolve most of those challenges. The Gateway API is a layer currently not added in the deployment of our Kubernetes cluster, but I guess it should be added by default in the future. The concept of Gateway API is to extend the current way of managing our network by adding new CRDs helping us to configure our network rules. It provides features helping us to define the Kubernetes service network for different personas of our cluster, the infrastructure provider, the cluster operator, and the application developers. So the cluster operator and the infrastructure provider will be in charge of creating a gateway class and the gateway to expose out of the cluster our services. They would be the one in charge of defining the level of security required to accept incoming traffic. Then, the advantage is that the gateway would be shared between namespaces. It means that each project would have the options to attach route to an existing gateway. The Gateway API introduces new CRDs to create the gateway, the routes, and more. If you want to take advantage of it, you will need to deploy the Gateway API, including the various CRDs and an existing implementation of the Gateway API. The implementation will probably deploy the GatewayClass. It happens that the deployments of the implementation also add the Gateway API CRDs. Before jumping into the details of each CRDs, let's remind why we would like to migrate of Ingress controllers that are perfectly working to the usage of Gateway API. Well, there are several reasons. First, like explained, the configuration of the Ingress holds 2 settings managed by 2 distinct roles: the routing of the app, in charge by the product team, and the common security settings that is managed by the platform owner. So the Gateway API will simplify the process by separating those settings. The second limitation of Ingress is that all scenarios such as rate limit, traffic split, and more are currently managed with annotations. So it means that we need to deploy several Ingress rules to build our canary releases settings. And the annotation used are very specific to the Ingress controller implementation, like Nginx or Kong. So which means if you're moving to one controller to the other, you will have to revisit all your Ingress rules. Next, the Gateway API is standardizing the way we define our network rules in our cluster, which would simplify our journey to migrate from Ingress to Service Mesh. Last, it is not really related to Ingress anymore, but the API Gateway is providing a standard set of objects to configure the network. If you want to easily configure and transition to Service Mesh or migrate from one Service Mesh to any other, then the Gateway API will simplify that tasks. The advantage of the Gateway API is that with all those CRDs, we can configure various types of use cases. So obviously we have the traffic split, the URL rewriting, the redirect rules. We can secure communication between namespaces, and last, create Ingress rules using L4 to L7 policies. Like explained, the Gateway API only provides the API, the CRDs, and how we are basically standardizing the way we're going to manage our traffic on our cluster. To use the Gateway API, it will require one of the current implementation of the Gateway APIs using Nginx, Kong, Traffic, Istio, and many others. The Gateway API, like mentioned, introduced 4 distinct CRDs. The Gateway class will define which implementation will be used for the Gateway API, the gateway that will map incoming traffic to a service in the cluster, the routes defining how the traffic will be mapped to our services. Like explained, there are 4 CRDs introduced, so let's cover them one by one, starting with the Gateway class. The Gateway class covers the entire cluster. The Gateway class is a bit similar to the Ingress class or the storage class that defines which implementation would be used for this type of use case. In the case of the Gateway API, it would refer to the gateway controller deployed in your cluster. It means that we need to have at least one gateway class defined in our cluster. We usually don't configure the gateway class. This CRD would be deployed by one of the available controllers implementations of the Gateway API. Currently, there are several implementations flagged as experimental or beta. So here is the link to the various implementation currently available for the Gateway API. We have EKS, Apache, Cilium, Envoy, Nginx, Kuma, Istio, and so on. The gateway defines how the traffic would be managed to reach the service. A gateway needs to have a gateway class, helping Kubernetes to rely on a specific gateway controller. The gateway CRD won't define the route and which service would be used for this gateway. This would be done with one of the CRDs defining the route. The Gateway CRD is the place where we would be able to define the TLS settings that we would like to use, the listener, which port is exposed and which protocol is accessible out of this cluster. And we also have the options to filter to routes deployed in specific namespaces or namespaces having specific labels. Last, we can also define addresses that will be bound to this gateway. For example, if you're using an external load balancer or a proxy, you can refer to the IP address of this component to limit the access to the gateway from specific IP addresses. So let's have a look at a simple gateway. So here is an example of a simple gateway. Here we only precise that we expose the HTTP port 80, and we use the class name default example. So let's do the same, but adding a TLS settings. So here is another example. As you can see, the TLS relies on a certificate stored in a Kubernetes secret. And if you want, we could limit this gateway to use routes deployed in specific namespaces. So here is an example. In this example, this gateway will only be usable by routes that is available in the namespacing having the label expose apps equal true. Routes define rules based on the protocol. It will map a request from a gateway to a Kubernetes service. There are several types of routes. There is the HTTP routes handling HTTP and HTTPS that will inspect HTTP traffic to route to the right service. The routing can be based on HTTP headers, for example, or HTTP URL parameters, and so on. HTTP routes could also add and modify the headers on the fly. TLS routes. This TLS object is here to manage the traffic, the TLS traffic within our cluster to figure out which service will receive the TLS traffic. TCP routes and UDP routes will map the gateway to service based on one or more TCP UDP ports. And last, we have gRPC routes is to route specifically the gRPC traffic. So at the end, gRPC route and HTTP route will allow us to create rules on the layer 7. The other are only on the layer 4. In the route, you will precise the parent ref, which gateway would be used for this route, the host names, similar to Ingress rules. You can also define in your route the reference to a specific host name, where the evaluation of the routing will be based on the HTTP header host name. Rules. It defines the service of this namespace that will receive the traffic with the help of the backend ref. What is great with backend ref is that we can refer to several services to build, for example, a traffic split, where we want to have 80% of the traffic on a given service, so using the weight parameter, and 20% on the other services. Those rules can rely on HTTP headers or URL parameters and so on. Matches. It allows us to create a list of rules to define how the traffic will be routed to the backend service. You can have several matching rules. The route will handle the traffic if one of the rules are respected. You can make rule based on the path, the header, the query parameters, even the HTTP method used. You can also precise filter rules that allow us to modify the structure of the request by adding or dropping headers, or do some URL rewriting or request redirect, for example. So here is an example. In this example, we are routing the traffic having the path /edit request header to the backend service echo. Once the route has been done, we will also add an HTTP header in the request called myHeader. With the HTTP route, we can imagine to create advanced L7 routing rules based on the header values or even the query parameters of the request. For example, in this example, we will route the traffic to the service coffee v1 svc if the path is coffee, and to coffee-v2 svc if the header version has the value 2, or if the parameter has the variable test equal v2. The L7 rules will allow us to define traffic split rules using the weight parameter, like mentioned before, in the backend ref definition. So here is an example of a traffic split rules. In the backend ref, we have the service foo v1 on the port 8080, and there's a weight of 90, so 90%. And then we have the foo-v2 on the port 8080 with a weight of 10. So with the weight, we'll define how we're going to split the traffic. Reference grant. The reference grant CRD is a way of securing communication of services between namespaces. Currently in Kubernetes, there are no limitation to send communication between namespaces, except if we create network policies. Communication between namespaces could be at the end considered to be vulnerable. The purpose of a reference grant is to authorize a traffic from an object coming from other namespaces. For example, I'm creating an HTTP route in namespace A, and there is a rule based on the path where I would like to forward the traffic to a service deployed in the namespace B. Then I would need first to create a reference grant rule in the namespace B, and then define the HTTP route in the namespace A. So here is an example of this reference grant deployed in the service B. Then we can define our route in the namespace A. So here is the HTTP route that we're going to create. In this tutorial, we will deploy the OpenTelemetry demo application and expose it using the Gateway API. For this tutorial, we will use the Nginx implementation of the Gateway API. We'll configure the gateway and the HTTP route to define our Ingress role. For this tutorial, we'll need to have, of course, a Kubernetes cluster, the cert manager required by the OpenTelemetry operator. So at the end, we deploy the OpenTelemetry operator. We will deploy the Gateway API, the Nginx Gateway controller, and of course, the OpenTelemetry demo application.
Like every tutorial delivered in Is It Observable, there is always a GitHub repository related to the episode. And here we're looking at the repo for the Gateway API. So, like explained, we're going to use the hotel demo, Dynatrace to send the traces produced by the hotel demo, and we are going to deploy the Nginx Gateway controller, which is still experimental. So what I would suggest, there are a few requirements. Of course, you need a trace tenant. It's not specifically required, but if you want to see the traces coming in through the application, you will. If you don't have the tenant, I will suggest to create a new tenant to start a new trial here. Put your email address and you will receive the traces. To send the traces, there are two information like usual that I usually provide as a requirement is the access token. So if you go to access token here on the left menu, you click on generate token, and we are going to send not logs today. So it's going to be mainly metrics and traces, but obviously you can select the three of them. So logs, metrics, and traces. You will click on generate, and once it's been created, make sure to copy the value, save it into one of the variables that I shared in the README file, because you will need it to run the deployment script. The other thing is the tenant URL. So copy the entire tenant URL. You will need it because this will be used again to configure the collector of the hotel demo applications. So that's about for the requirements. So then you will run the script. So here you can see that's mainly just about running the script. So I will go deeper in the settings of the gateway and the HTTP routes. It's a very simple one that I created, nothing fancy, no traffic split or anything like this, just pure Ingress rules, and you'll see how it works. But one small note. So let me bring my terminal. What are you going to expect from this in your cluster? So if you look at, for example, if you look at the namespaces, you will have a few namespaces available. So first, the cert manager and the hotel operator systems. Those are the one because we are using the operator to deploy the collector for the hotel demo. Then, because this will deploy the API gateway specific CRDs and things, you have obviously the gateway systems available, and then you have the Nginx gateway. So just small note, the Nginx gateway is coming from one of the implementation in the Kubernetes Gateway API. I picked the Nginx gateway controller, and as you can see, it brings you to a GitHub repo, and it's if you want to deploy it. So to deploy the Nginx, so I have already in this repo of the Nginx Kubernetes Gateway controller. There are a couple of files, the Nginx configuration file, the airbag, the namespace, the GatewayClass, the deployment. So all of those things has already been cloned and stored in the repo that I provide for this control. So that will deploy everything. And the second thing is once you deploy it, but you will have to deploy a service. And in my case, I use the load balancer service. So by doing this in the Nginx Gateway namespace, you're getting an IP address, external IP address, to be able to expose your Ingress rules. If you now look at the various parts, so if you look at first at the default namespace, obviously one instance of the collector per node, in my case 2 nodes. If you look at the hotel demo, we will have, of course, all the pods of the hotel demo. Just quickly, we have all the pods of the hotel demo. And the second thing is obviously the Nginx gateway, which is the one that we are going to touch. Slightly modified the gateway. I will explain it in a few seconds. What I did, you can see that it's 2 containers. One is the gateway and the other one is the traditional Nginx. You can see that I have the hotel demo here with the various folders, and there is a specific folder for the gateway. So on the gateway side, I have one YAML file. So here you can see that's the load balancer that will be used to expose the Nginx gateway and create an external IP address. Of course, this is not required, but if you want to do Ingress, you obviously need it. In my case, I have in the gateway YAML file, I have created my gateway and my HTTP route. So the gateway will be deployed in the Nginx, in the hotel demo namespace. I am playing with the hostname header file. So then if I come with this specific hostname, so if you do a curl, you need to pass that header host name with the right value to let the gateway authorize the traffic. So basically it's looking at the header to fork it. As you can see, no reference of anything, no TLS, no reference of any allowed route or anything like this. It's basically just saying I am exposing that port and for specific host names variables, and that's it. On the other side, I have the HTTP route. Here, the HTTP route is basically referring, as I explained, to the previous gateway. And then the rule is very simple. Whatever comes in, so I didn't put any rules into the path because by default it's going to be the full path prefix slash, and which is all the various slash, all the various URLs of the hotel demo. So I didn't add it because by default it will add it the slash as authorizations. So I just explained that I want to basically forward the traffic to the front-end service of the hotel demo application on the port 8080. So this is very, very simple, nothing fancy. As a consequence, if we open the browser and I type my own URL with the host name, the neat.io will resolve the DNS for me. That's great. And I am able to expose the hotel demo applications using the traditional Gateway API. For this particular tutorial, what I try to achieve is to enable the instrumentation on the Nginx gateway, because the Nginx gateway doesn't provide any specific instrumentations by default. So what I thought could be useful is to look at a repo. For those who are not familiar with that, but I want to share with you, there is the OpenTelemetry C++ contrib instrumentation repo. And if you look at the instrumentation, there is one for Nginx. So what I try to do here is to basically rebuild and try to follow these instructions to use custom version of the Nginx in the gateway. Because if you pay attention to the deployment, so I've changed the deployment files again, but if you pay attention to the deployment, there's a gateway, Kubernetes Gateway container, and then there's another container in the deployment Nginx. And I modified this image with the new version of the Nginx instrumentation. So if you look at there is the get docker file if you want to try it out. So I just did some tests here. That adds an extra module and then in the configuration, so the Nginx conf is a config map, which is here, where I basically load the module that I have added in this version of Nginx. And then there are various properties and a file to load. The file is here, but it's failing. So it's not working for some reasons. I'd like to take more time to investigating this because I think it could be useful to get also somehow traces out of the gateway. Anyway, what I did also is try to add the log format for this the Nginx pod. So if you open the terminal, so as you can see here in the log files, I have some errors generated from the OpenTelemetry module here, and it has some issues. So I need to investigate a bit more to figure out why we're getting those issues, because technically what it is supposed to do, it seems that I'm almost close to have it. It will generate spans out of Nginx in this particular gateway controller, and I think that could be a valuable assets to get traces, and then we can generate metrics with span metrics, for example, on the collector. So never mind. So this is not working, but again, like I said, I will try to resolve it with more time in front of me. But the logging is here on this Nginx, which means if you have a low key, or if you have a Flint bit or the collector, I didn't do the log collections from the collector perspective. You should get the logs, and then from there you could basically parse the logs and visualize the logs. Which means technically, if you look at the documentations, I have passed to this OTel, because usually the module is supposed to recognize the traditional OTel environment variables. This is where I got my collector URL, but obviously here there's settings which is not working, because we are just getting errors after errors for each individual request coming in the system. Otherwise, what we could have done is also try to enable the status page, which I try to do, but obviously the status page still is not there as well. So there are a few observability pieces which is missing, I would say, but I'm pretty sure that once we are moving from an alpha release to a more stable release, the observability piece will be obviously added out of the box. I'm using vCluster, so I have one cluster hosting several environments, several things. And in the main cluster that hosts all those vClusters, I have the Dynatrace operator. So even if I'm not producing traces, except from the OTel demo application. So if you look at one of those, this is the OTel demo services from the Gateway namespace. I have suffixes with the Gateway something. If we look at the Gateway product catalog, for example, I will get some traces. I can see who is calling what from a Dynatrace perspective. So those traces are here. And this is what you will get. So if you go to services screens, you will get all the services. In your case, you will only see the services only of the OTel demo application. In my case, I get more. But one more important thing here, with the Dynatrace operator, it's instrumenting pods, automatically injecting the agents and trying to do some stuff about it, enrichment and so on. What I realize here is Nginx has been automatically instrumented. So if I look this Nginx service here, which is not OpenTelemetry, because we like mentioned, we failed. I failed in configuring the OTel demo, the Nginx instrumentation layer or module of the Nginx. But here, what I see here is that the Dynatrace agent has automatically instrumented. So I can see that the traffic is coming from the load generator, like expected. And then we get the front end will be the one that we were going to call, which is our Gateway API role. And then if I click on one of those paths, for example, you can see that we're getting to from the load generator perspective, we're going to Nginx, and then we're going to the front end. So at least it's interesting, and we're getting some details. And the interesting piece is that because it's Dynatrace, it tries to also to do some profiling. So I get some code modules and some timing and some details because of the presence of the Dynatrace agent.
That's it for today's episode related to the Gateway API. As you can see, the way of structuring the network using the Gateway API is clearly much more simpler compared to Ingress roles, where we separate the common rules on the gateway and the gateway class on one end. So those could be handled by the platform owners. And on the end, all the routing could be done by the product team. And also the fact that the Gateway API introduced L7 rules, we can even be more precise on how we want to route the traffic in our cluster. The other exciting thing is that the Gateway API allows us to introduce also features like the traffic split, naturally configurable through the HTTP routes or the gRPC routes and so on. Again, today we didn't touch base on the support of telemetry data. I looked at the Nginx controller provided for the Gateway API. It doesn't for this moment generate so much telemetry data except of the logs. But the idea of this episode is to introduce the Gateway API to be able to cover other implementations like the ambient mesh, for example, which is an exciting service mesh implementation from Istio. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.